Hello and welcome to this short revision video about hypotheses. Hypotheses being the plural of hypothesis because we generally write two. A hypothesis is a testable statement which you write, which allows us to decide whether our research has been successful or unsuccessful. Hypotheses should always be precise and should be operationalized, which is put in terms of exactly how you will measure what you're measuring. By convention, we always write two, hence hypotheses. You write a null hypothesis and an alternative hypothesis. The null hypothesis states that there will be no relationship between the variables that you are studying. Or it says that any results that you've got are down to chance. And this is where statistics come in. More about that later on in the course. So good examples of null hypothesis: cats show no preference for food based on its shape. Or a plant growth is not affected by light colour, or age has no effect on musical ability. You are saying effectively that there is no relationship between the two variables that you are looking at. The independent variable has no effect on the dependent. An alternative hypothesis states that there is a relationship between the two variables and that this relationship is significant. Again, this is a term based on statistics. We use statistics to work out the chances that the results that we've got have happened by accident. And it will tell us down to a 99 or a 95% chance that these results did not happen by accident. More on that when we come to statistics later on in the year. And what we do once we've got that is we weigh up between the alternative and the null hypothesis. Okay, so these results didn't happen by chance, they are significant. Therefore, I'm going to accept my alternative hypothesis that the independent variable did affect the dependent variable, or they're not significant, so I will accept my null. When it comes to writing alternative hypotheses, you write them in one of two forms. They can either be directional, also known as one-tailed, or non-directional, also known as two-tailed. Now, you may remember the crazy cat. So, for instance, if we expect short-term memory to decrease as age increases, that's a definite prediction. We're saying as you get older, your short-term memory will decrease. That shows a direction, decrease. As you see, a one-tailed cat, we can tell what direction it's walking in, that way. And it says that you know specifically what effect the IV is going to have on the DV. It will decrease. So generally speaking, if the hypothesis has a phrase in it that shows direction, increase, decrease, higher, lower, more, fewer, any of these sort of words, then that is a direction. That is a prediction of an exact result. However, you may not know what your direction is going to be, in which case you would write a two-tailed or a non-directional hypothesis. In the case of Freak Cat, we don't know which way Freak Cat's going to walk. Could be this way, could be that way. And in that sense, if you're not sure, you write a non-directional hypothesis. In this case, with the STM example, the duration of STM will be affected by an increase in age. We don't know. It could get better, it could get worse. As a general point, you should not ever state that a hypothesis can be proven. A hypothesis supports an idea or suggests an outcome. It doesn't prove it. We can't say with 100% certainty that evidence won't come along that will prove us incorrect. So we avoid using terms like proven. The other thing to be aware of is if you're doing a correlation, you would write a correlational hypothesis. This works in exactly the same way as a normal hypothesis. You still create a null, but instead of talking about the IV and the DV, you just talk about your two covariables. So to write a directional correlational hypothesis, you would say there will be a positive correlation between X and Y, or there will be a negative correlation between X and Y. If you're writing a non-directional version, you just say there will be a correlation between X and Y. You don't state whether it will be positive or negative. And then the null would be there would be no correlation between X and Y. So if, for instance, your correlation is about ice cream sales and murder, you may remember that example from the lesson, you might say there'll be a positive correlation between sales of ice cream and the murder rate. Or you might say there will just be a correlation between sales of ice cream and the murder rate. And you would always have the null, which is there will be no correlation between sales of ice cream and the murder rate. Chances are in the exam you will either be asked to identify what type of hypothesis is being shown, or the slightly harder version, then you will be asked to write a hypothesis. So there is a step-by-step guide here for you to write down if you need to on how to write a hypothesis. The first step when you're writing a hypothesis is to identify the variables in the study and operationalize those variables. So you need to think, right, what's the IV and what is the DV? Or in the case of a correlation, what are the two variables being studied? And then, as I say, you need to operationalize those. So read the little question stem that you've been given. How are they being measured? Look specifically. Is it something like the number of words correctly recalled, which is the case in about 90% of studies of memory? But don't just say better memory, say the number of words correctly recalled. Then you need to decide on a direction. Again, look at the stimulus material, the question stem. If it mentions that there's prior research, then that will provide the direction. If it says previous research has shown STM decreases with age, then you know it's a direction. If it doesn't mention any previous research, or more often the case, will have a line in it saying the researcher was not aware of any previous research, then you opt for a two-tailed non-directional hypothesis. So the clue will be in the question. Make sure you read the question stem carefully. And then finally, write your hypothesis. A good hypothesis will be short, it means concise, it will get to the point, and it will use clear and simple language. So read the question stem carefully. What are the IV? What is the DV? How are they being measured? And then phrase it in terms of those things. Okay, so the key terms that you need for hypotheses are alternative hypothesis and null hypothesis. Remember, the alternative hypothesis can be referred to as the experimental hypothesis if the research method is an experiment. Directional versus non-directional, one-tailed versus two-tailed. Remember, directional and one-tailed mean the same thing. Non-directional and two-tailed mean the same thing. And then finally, operationalization, which is how is it going to be measured? How is it operationalized? Okay, hopefully that all makes sense. Read through your texts. Make sure that you know this stuff. It's a very, very common exam question. And let me know if there's any problems. Bye now.